Today I'm reading this paper, iPrompt, explaining the data patterns in natural language via interpretable auto-prompting, which is one of the most creative prompt papers that I've read in a little while. The paper was originally released on arXiv, I think in October of last year, but they have published a V2 in, I'm pretty sure this is just Jan 2024 actually. So, what is iPrompt doing? Well, they take input and output data. We can look at this graph here. We take input and output data and then send a data set to your LLM to try and generate an explanation of the input. Say, how did we get the number 4 from the input 3 and 1? How did we get the number 11 from the input 4 and 7? And any reasonably good pattern solver will say this is addition right here. So explain a known data set is one of the things that they're saying that you can do with this, and you can validate how well it does. But you could also try to figure out and learn a good prompt for transitioning from an input to an output, and then perhaps finding novel descriptions. Maybe this data can be characterized by a very complicated function that is known, but it could also be characterized by a simpler function that hasn't yet been found. So they talk about this idea generally. I mean, it's a lot of background on prompting and whatnot. And they discuss a little bit of the related work of how other people are trying to do this, but what it really comes down to, in my opinion, the interesting piece that they talk about here is not any of this, but the fact that for each input-output, they're going to generate multiple potential solutions, potential answers for what is this doing, and they're going to do it in natural language, which is quite important when it comes to what these models are strong at. So one approach to this instead would be to say, let us try to quantify the data 3, 1, and 4. 3 and 1 are arguments, 4 is the output. Let me try to write a mathematical expression which I can translate 3 and 1 into 4. And that will work for precise and clear inputs like this. It wouldn't work if your data set is a traditional natural language data set. So instead they take this approach of using natural language to describe the transformation function. And then they rank these. They send it back to the LLM, say, rank this. But a key piece here is that they use these as instructions for solving the actual inputs and outputs. So the way that they rank is by saying, use this as an instruction. Combine the numbers as the instruction with the input 3, 1, and the output is 4. Is this a good instruction for solving this? And in that way, they're able to find, here are the best ones. They iterate by chunking or trimming their high-ranking instructions. So they will start with combine the numbers and then drop the word numbers and get GPT to decode a few more tokens with a higher temperature to give you combine the numbers but also combine the arguments. And the idea here is that we would be keeping each functional word but exploring the space of different ways of prompting the model. And so sum the numbers, or sum in order, or sum all the inputs. And again, you can rank these to say which one of these is the best. And then use this as your final instruction on this data set. So they show using this technique, they're able to find good instructions for telling GPT how to answer a data set. And they report a few different results here. I think the results are actually not the interesting part, in my opinion. It seems kind of obvious that this would happen, But to creatively come up with the idea of doing this, finding this transformation function by using first GPT to write the transformation function, and then second to actually use that instruction as an instruction with the data set to evaluate it. So I think this is a pretty cool piece of work. They do mention that it is open source as well, but again, I don't think the implementation or the results are the important part here. I think it's actually the fact that when you're building something and you're trying to set up your prompts, or you have some data that you don't quite know how to prompt, this could help guide you on a path towards finding the perfect prompt for what you're doing. The last thing I want to call out with it is that they have kind of a weird ablation where they show that if they take out the iteration, they don't have very good results at all. So with no iteration on finding a good prompt, once they have combined the numbers, they say combine the arguments, combine the inputs. If you take that piece out, what they claim is that accuracy drops, or the MRR drops to 0.075. I don't know if I actually believe this. It seems like you can get most of the way, you should be able to get most of the way there just with the initial setup, but perhaps they aren't showing kind of the average example with this graphic up here. This might be cherry picked as like a very clear example, but my hunch would be with any of the generated ones here, or with the before iteration generated instructions, these should work. So maybe those are simplified and therefore don't need iteration, but some of the complex ones do need the iteration. And then they also show that if you take out the examples, you similarly struggle. So that's all for this one. I think I'm very interested in trying this out in my own work, so I would recommend you guys take a look too. If this paper was interesting to you and you want to work on something like this, send me a message, and I've got a Discord server where I work with various students and non-students to read through papers like this and try to build and recreate them. So send me a message.